The Science of Do, How Nuclear Bombs Work, 0000 to 0130. Introduction, the hook visual, slow motion footage of a nuclear fireball expanding. High intensity cinematic music. Narrator, imagine a grain of sand. Now imagine that grain of sand holding enough energy to level a city block. In 1945, the world witnessed the impossible, matter turning into pure energy. But how does a piece of metal no bigger than a grapefruit trigger a chain reaction that burns hotter than the surface of the sun? Visual. Title card. How Nuclear Bombs Work. Narrator. Today, we're stripping away the mystery. We're going inside the atom to see the terrifying physics of fission and fusion. This is the science of the world's most dangerous weapon. 130 to 4. Part 1, the core ingredient, the atom visual. 3D animation of an atom. Zoom in on the nucleus. Narrator. To understand the bomb, you have to understand the strong nuclear force. This is the glue that holds the nucleus of an atom together. For most elements, this glue is permanent. But for some heavy, unstable elements like uranium-235 or plutonium-239, the nucleus is like a Jenga tower. One wrong move and the whole thing collapses. Visual. Comparing U-235 and U-238 in a graphic. Narrator, not all uranium is created equal. Most uranium found in nature is U-238, which is stable and boring. To make a bomb, you need U-235. It's fissile, meaning if you hit it with a single neutron, it doesn't just absorb it, it shatters. Visual. Animation of a neutron hitting a U-235 nucleus. It splits into two smaller atoms. Narrator. This is nuclear fission. When that atom splits, it releases two things, a massive burst of energy and 2 or 3 more neutrons. These new neutrons fly out and hit other uranium atoms. If you have enough uranium, what we call critical mass, you get a chain reaction. 4 o'clock to 6:30, Part 2, the atomic bomb, the fission trigger. Visual. Diagrams of Little Boy, gun type, and Fat Man, implosion type. Narrator. There are 2 main ways to trigger this explosion. The first is the gun type design used in the Little Boy bomb. It's surprisingly simple. You take a slug of uranium and fire it down a barrel into another piece of uranium. When they collide, they reach critical mass and boom. Visual. Animation of the implosion type mechanism. Narrator. The second method is more complex, implosion. This was used in the Fat Man bomb. You have a core of plutonium surrounded by high explosives. All the explosives fire at the exact same microsecond, squeezing the plutonium core inward. This compression forces the atoms so close together that the chain reaction becomes unstoppable. 6:30 to 9:30. Part 3, the hydrogen bomb, the power of the sun. Visual. Transition from blue/white colors to bright orange/red. Show a thermonuclear diagram. Narrator. If an atomic bomb is scary, the hydrogen bomb or thermonuclear bomb is a nightmare. While an A-bomb splits atoms, an H-bomb fuses them together. This is nuclear fusion, the same process that powers the sun. Visual. Diagram of the Teller-Ulam design. Narrator, here is the crazy part. To start a fusion reaction, you need millions of degrees of heat. So how do you get that? You use an atomic bomb as a matchstick. Inside an H-bomb, there are 2 stages. The primary, a fission bomb. A-bomb explodes. The secondary, the X-rays and heat from the first explosion compress a cylinder of hydrogen isotopes, deuterium and tritium. The atoms fuse together, releasing energy on a scale that makes the Hiroshima bomb look like a firecracker. We are talking about E=mc² in its most violent form. 9:30 to 11:30, Part 4. The aftermath, thermal blast, and fallout. Visual. Infographic showing the radius of an explosion. Narrator. A nuclear explosion kills in 3 ways. Thermal radiation, a flash of light so bright it vaporizes everything near the center and causes 3rd-degree burns miles away. Blast wave. A wall of compressed air that flattens concrete buildings like they're made of cars. Radioactive fallout. The mushroom cloud isn't just smoke, it's pulverized radioactive dirt. It drifts with the wind, poisoning the land for decades. 11:30 to 1300. Conclusion visual, host on camera if applicable, or somber shots of the Earth from space. Narrator. Today there are over 12,000 nuclear warheads on Earth. The physics that allows us to create carbon-free energy in power plants is the same physics that can end civilization. We've mastered the atom, but the challenge of the 21st century is mastering our own restraint. Visual, a subscribe button, and end screen. Narrator. If you want to see more deep dives into the science of the world's most powerful tech, hit that subscribe button and ring the bell. Thanks for watching and stay curious. Technical formatting notes for the creator equations: use E equals mc squared for the energy mass equivalence units. Use Celsius or Fahrenheit for temperatures.